Hello friends, welcome back to the channel. Today is day 7 of our JFrog Artifactory series, and in this video we are going to learn about Docker repositories in JFrog Artifactory. Before we start, let's clear one important concept. Both Docker and Artifactory use the word repository, but they mean slightly different things. What is the difference? Well, Docker repository is a hosted collection of tagged Docker images. Each image represents a file system for a container. Where Docker Registry is a server that stores and serves these Docker repositories, example Docker Hub. Then what is an Artifactory repository? An Artifactory repository is a hosted collection of Docker repositories. Essentially, Artifactory acts as a Docker registry but with many enterprise features on top. In Artifactory documentation, an Artifactory repository for Docker images is also called a Docker repository. Now, why do we use Artifactory as your Docker registry? Because it provides secure and private registries. Host your Docker images in controlled, secure environment with fine-grained access permissions. Native Docker Registry API support. Artifactory supports Docker Registry APIs, so you can pull, push images using a native Docker CLI without any extra plugins. There are local, remote and virtual repositories. Local repository means store internal images. Remote repository for cache images from Docker Hub. Virtual, it combines multiple repos under a single URL. CI/CD integration means Artifactory connects smoothly with your build and deployment pipelines, so your builds, testing and the deployments all run automatically. High availability and redundancy means your Docker images are always accessible. Even if one server goes down, Artifactory setup keeps everything running with zero downtime for your teams. Today we will see how to create a Docker repository in JFrog Artifactory for our SEH project. We will also learn how to create Docker files for both our Spring Boot application and our React application. Next, we will connect to Docker client to Artifactory. We will manually connect to Docker CLI by setting the Artifactory credentials inside the /docker/config.json file. Then we will see how to push Docker images using Docker CLI. And finally, how to pull Docker images using the Docker CLI. Let's start with a quick recap. What exactly is Docker? Well, Docker is a platform that allows you to develop, ship and run applications inside isolated environments called containers. In simple words, Docker is a containerization tool. These containers help you run your application consistently across different environments because all dependencies are packaged together. And when you integrate Docker with JFrog Artifactory, you get a secure, private and a powerful registry for your Docker images with complete control over your development and delivery pipeline. Now let's create a Docker repository. Before we push or pull any Docker images, we need a Docker repository in JFrog Artifactory. So today we will see exactly how to create one. Just a quick recap. In JFrog Artifactory, we have three main types of repositories. Number one, local repository. These are used to store and share your organization's own packages, like your in-house builds or custom artifacts. Number two, remote repositories. These let you download packages from remote locations such as public registries or even other Artifactory instances while caching them locally. Number three, virtual repositories. These combines both local and remote repositories into a single logical endpoint, which means you get one clean URL to access multiple package types without any complexity. Let's start by creating a Docker repository in JFrog Artifactory. First, log into Artifactory using your admin credentials. Go to Administration tab. Click on Repositories. Then choose Create a Repository. So Artifactory will ask what type of repository you want to create, local, remote or virtual. Since we want to upload our Docker images, let's create a local repository. So click on Local. Now select the package type as Docker. Now we need to fill in the required details. One important note, don't use underscore in the repository name. So instead of writing something like sh underscore docker, use a hyphen in the name, like sh hyphen docker for our sh project. In the Docker settings section, set the API version to v2 and set the max unique tags and the Docker tag retention values based on your retention strategy. This is how Artifactory decides how many tags to keep and when to clean up older ones. And other details are okay. Once everything is filled, click create local repository. Your repository is now created and you can see the successful message here. So you can set up the Docker client from here or can select I will do it later, so that later on you can configure. So I am clicking on I will do it later. So our SCH Docker repository being created and the package type is Docker here. So there is one more thing I want to show you. Artifactory also lets you create repositories using pre-built setup. This is super helpful when you want all the related repos created automatically without doing each one manually. So for that, under create a repository, click on pre-built setup. From here, choose the package type as Docker. Give it a prefix, for example sh-test. Since we already created repo earlier with the prefix sh, so I am using sh-test now. So the moment you click create, Artifactory automatically generates 3 Docker repositories for you. One is local repository named sh-test docker local. The another one is a Docker remote repository named sh-test docker remote. This points to Docker Registry, and a Docker virtual repository named sh-test docker. So with one click, you get all 3 local, remote and virtual ready to use repositories. So click on create. Once it is created, Artifactory shows a message saying your Docker repositories was created successfully. So from here I am selecting continue. So here Artifactory provides you 2 options. One is what would you like to connect to, CI tool or Docker client. If you select CI tool, you will see integration options for GitHub Actions, Circle CI, GitLab CI, Jenkins, Bitbucket pipelines, Bamboo, Azure DevOps, TeamCity, other CI. We will cover CI integration later in this series. So for now, just click back button. Now select Docker client. This is where we set up our local Docker client to push and pull images from the Artifactory registry. So from here, you will get Docker login option and you will get the option to generate a token. So just copy this and you can run it on your terminal. I am saving it for now. So when your terminal asks for your password, enter your identity token. It will take some time. Once done, click on next. You will get pull and push commands. Once you are done creating the repositories, you will see all of them listed in your Artifactory panel. Now let's move on and understand how to create Docker images for both our Spring Boot application and our React application one by one. We will start with the Spring Boot application. At the project level, I am inside my Spring Boot code base, sh students. So you can see Docker file along with other project files. So here is the simple Docker file that I am using. Let me quickly explain what each line does. So we are using an OpenJDK base image. A base image is required, so our container already has Java installed before running our Spring Boot.jar. Then workdir/app. This sets the working directory inside the container. Think of it as running cd/app inside the container. Then copy target/start.jar to dot. So this copies the generated Spring Boot.jar from our local target folder into the /app directory inside the container and this jar is getting generated when we run mvn clean install inside our target directory. Then expose 3000. We expose port 3000 because our application runs on port 3000. So we can validate this under src main resources application.properties. Here server.port is 3000. So the container will listen on port 3000. Then finally cmd java-jar star.jar. So this command starts the Spring Boot application inside the container by running the .jar file which is available inside our /app in the container. Now let's create the Docker image using the Docker file we just discussed. Docker is already installed on my local machine, but you can run the same commands on any server where Docker is installed. To build the image, we use Docker build command. The format is docker build -t, then app name and the version number, so we can get it from pom.xml. App name, colon, version number, and dot. So here -t tag is used to tag the image. So here we tag the image with the application name and the version number taken from pom.xml. In my case, the command looks like docker build -t, then application name /students, version number 001, stable version number, and then dot. The dot at the end is very important. It tells Docker to look for the Docker file in the current directory. Once this command runs successful, Docker will create the image for our Spring Boot application. So to verify the image, we can run docker image ls or docker images command. So we can see our image is being created. Now let's connect our Docker CLI to JFrog Artifactory. Well, there are two ways to configure Docker to work with Artifactory. One is using docker login command, and another one is by manually setting credentials in docker config file. In your JFrog Artifactory, open your Docker local repository, which is SES Docker in my case. On the top right corner, click Set Me Up. Here Artifactory asks for authentication. To create a client setup with embedded authentication, you need to generate an identity token. Just enter your JFrog account password. Click on Generate Token and create instructions. Artifactory will now show you the command. So using this docker login command, you can log in and you can pass for a password. You can provide the password and you will be able to log into Artifactory. The another method is manually setting Docker credentials. So you can also configure Docker manually. For that, you need to go to Docker config file. So my Docker config file is available inside C drive users admin.docker. Open this config.json file. So inside the auth section, add the snippet provided by Artifactory. From here, copy this and paste it here. Save it. Now your Docker CLI is authenticated with Artifactory. Before pushing, we need to tag the image in the correct folder structure so that Artifactory stores it cleanly inside your repository. For that, under push tag, we will get the command to tag. Copy this command. So this is Docker tag, then image name. Our image name is this one. Copy this. App name version number, and here if we want to follow certain folder structure, we can provide that. For example, inside SES Docker repo, app name should be there, then version number, and then our image name. Copy this command and run it in your terminal. Once done, we need to push. For that, we can copy the push command from here, paste it here, update it using our new image. And run the command. Docker push, then image name. So once the push is successful, you can go to Artifactory. Here refresh. Here you can see this is my Docker Artifactory, then app name, then version number, and then image is available. Here we can see our image is uploaded with the exact folder structure we provided. Now let's follow the exact same steps and create the Docker image for our React frontend application, and then push it to our JFrog Docker repository, which is SES Docker in our case. Just like we did for Spring Boot service, we will maintain the same folder structure inside the Artifactory for consistency, like SES Docker, then application name, version number, image name, and then version. We already have a Docker file at the project level. Right, let's go through this Docker file step by step. First stage is build React app. So we start with from instruction. Here we are using Alpine image. This means we are using a lightweight node image just for building the React application, and we call this stage as build. Then we have workdir/app. This sets the working folder inside the container to /app. All commands will now run inside this folder. Then copy package.json and package.log.json to /. We only copy the dependency files first, so Docker can cache this step and speed up future builds. Now npm CI. This installs all the dependencies exactly as listed in the log file. We use npm CI because it's faster and guarantees a reproducible build. Now copy dot to dot. We copy all the project files into the container, so it has everything needed to build. Finally, npm run build. This compiles the React app into an optimized build folder ready for production. The second stage is runtime. Now we start a fresh image from node 18 Alpine. This keeps the final image small and clean up running the app. Then we set up the working directory again. So this is where our application will live in the environment. Next, copy from build /app build /build. Here we copy our build React files from the stage build, and no source code, no dev tools. Then copy package.json and package.log.json. We copy package files needed to install runtime dependencies. Run npm CI installs exactly the production dependencies, no dev dependencies here, keeping the container smaller and secure. Expose 3000 tells Docker the app will run on port 3000. This helps when mapping ports outside the container. Finally, cmd. This starts the application inside the container. Here we are using multi-stage Docker file because multi-stage keeps the final image lightweight, removes unnecessary builds tools and dev dependencies. It improves performance and security, and it packages only the production ready build files. So we first build the React app using Node and then copy compile build output into a much smaller runtime image. Now we need to build the React Docker image. For that, from our terminal, we will run docker build command. Docker build -t means tag. Here we need to provide the name of the image. Let's provide name as application name : we can provide the version number from here, package.json and dot. hit enter. So this will take some time because Docker builds layer by layer. Now let's tag the image. For that, copy this, copy the docker tag command. Need to prepare for SEH web app. Here SEH web app version number is 100. SEH Docker is the repository name. Then here SEH web app, SEH web version number is 100. So SEH web app :100, this is the local image you just built from your Docker file, and this one is the new image that points to our JFrog Artifactory Docker repository for following our structured folder format, that is repo name, then app name, version number and the image. Just copy this command and run it. So basically tagging tells Docker this image belongs in this specific repo path. If we run Docker images, so you will now see two images with respect to SEH web app. The original image we created from Docker file. The tagged image points to Artifactory. This is the one we will push. Now we need to push this image. For that, Docker push and then image name. Let's copy image name from here. Okay, once this push is complete, you can log into the Artifactory and validate from there. Let's wait for some time. So Docker push is completed. Now we can validate in JFrog Artifactory. Here, refresh. Here inside our Docker repository, that is SEH Docker, we can see two folders. One is SEH students, this is for Spring Boot application. Another one is SEH web app, which is for React frontend. Each folder contains the respective version of the app. So this structure keeps everything consistent, clean and easy to manage, especially as the number of microservices grows. Now finally let me show you how to pull a Docker image from the Artifactory registry. First, to make this demonstration clear, let's delete the local SEH web app image from our machine. Docker RMI -f, and this is the image ID. This way we can see the pull process from scratch. Now go to your Docker repo in Artifactory and copy the pull command. From here, click on set me up. You will see the pull command. Copy this and paste it here. Docker pull and the JFrog Artifactory repository. This one. Copy and paste it in your terminal. So this will download the image from your JFrog registry to your local Docker environment. If we do if we do docker image ls again, so here we can see SEH web app being downloaded. So today we learned how to create a Docker local repository in Artifactory, how to log into your Artifactory Docker repo using Docker CLI, how to build, tag and push Docker images for both Spring Boot and React applications, and finally how to pull images back from the repository. The same process applies if you want to use Podman instead of Docker. So from here, instead of Docker, you will need to select Podman and it will create the command accordingly. And that's it for today. If you found this video helpful, don't forget to hit like, share with your friends and subscribe to the channel for more tutorials. Thanks for watching and as always, happy learning.